actually changed in the last, what, decade? And how many people just haven't kept up?
Right. So our mission today is basically this. Pull out the key changes in Docker best practices, help you figure out why maybe some old habits stick around, and give you some real concrete ways to update your Docker game for, well, 2025.
Yeah.
Leverage its full power.
Sounds good. Where do we start?
Let's rewind a bit. Think back to maybe 2015. Docker was the hot new thing.
Oh, yeah, I remember the buzz.
Remember running that first Docker run ebit Ubuntu bash? That feeling?
Like magic, right. Instant Linux environment.
Exactly. It felt so powerful. And maybe you install Vim inside or Node.js, just tinkered around.
Definitely.
And let's be honest, back then, were you using dockerignore files?
Probably not consistently, no.
Running everything as root.
Guilty as charged, probably, in the early days, yeah.
And kind of seeing containers as just like a weird sort of VM.
Yeah, that was the mental model for a lot of us, I think. It was powerful then. But the article makes a great point.
Which is?
That same approach, the 2015 way, Schultz says it's actually holding you back now.
Right. Because 2025 Docker isn't that 2015 Docker anymore?
Not at all. It's matured. He calls it a fast composable production grade tool. But, and this is the big but, if you use it the right way.
Okay, so let's get into those habits, the things we need to unlearn. Where does the author start?
He kicks off with something he calls a pet peeve.
Oh.
Using the version field at the top of your docker-compose.yml files.
Yeah. I still see that sometimes.
Too. He says it's more obsolete than Bootstrap CSS.
Ouch.
And every time you do, a whale cries. Which is pretty evocative.
Yeah. Okay, so why is it bad? Apart from making whales cry.
It's just unnecessary now. It was needed for older versions of Compose to know which features were available, but modern Compose doesn't rely on it. It's just extra typing, extra noise.
So the advice is just start with services.
Pretty much. Keep it clean, start right with the services, block.
Okay, simple enough. What's next on the chopping block?
This one's bigger, no health checks.
Right. The author had a strong line on this, didn't he?
Yeah, basically. If your container crashes and you didn't configure a health check, that's on you.
Fair enough.
Yeah.
So why are they so critical? What do they actually do?
Well, think about it. How does Docker or Docker Compose know if your application inside the container is actually working? It might know the process is running, but is it responding to requests? Is it healthy?
Good point. It can't know unless you tell it how to check.
Exactly. So adding a health check gives Docker that crucial piece of information. It tells it, here's how you test if my service is okay, and if it fails the test enough times.
Then Compose can restart it or take other actions.
Precisely. It, as the article says, it turns Docker Compose into a viable production orchestrator for real. It's not just for dev anymore.
Can you give an example? Like, what does a health check look like in the YAML?
Sure. A common one for a web service might look something like this. You add a health check block under the service, and then inside that maybe a test.line.
Right.
Like test, cmd, curl, http.localhost.300. This tells Docker to run curl inside the container and try to fetch the main page. The def makes curl fail if it gets an HTTP error.
And you can set timings too, right?
Yep. Things like interval, 30s, timeout, 5s, retries, 3. So check every 30 seconds, wait up to 5 seconds for a response, and try 3 times before marking it unhealthy.
Got it. That seems pretty essential for anything beyond just playing around.
Absolutely. Essential for production, definitely.
Okay, next up, running as root. This feels like a classic security no-no, but people still do it in containers.
They do. And Schultz is very direct. Your container shouldn't be a liability. Running as root inside the container means if someone compromises your application, they potentially have root access within that container's environment.
Which is bad.
Which is very bad. It breaks the principle of least privilege. The fix, though, is usually quite simple. In your Dockerfile, you just add a couple of lines like rwoodn user-add -m appuser to create a user.
Okay.
And then uscr appuser to switch to that user for subsequent commands and when the container runs.
That's it.
That's the core of it. Now, there's a very important warning in the article.
Oh, let's hear it.
Just make sure that your volume mounts are owned by the non-root user. Otherwise, shit breaks. Trust me, I know.
Permissions. The eternal struggle.
Yep. If you mount a host directory, the appuser inside the container needs permission to write to it otherwise. Yeah. Things break. Something to keep in mind.
Definitely noted. Okay, what's habit number 4?
Not using a dockerignore file.
Right. The author paints a picture here. Nothing like shipping your .git, .env, and node modules to production.
Exactly. It sounds basic, but it happens. A dockerignore file works just like a .gitignore file.
Tells Docker what not to include in the build context.
Precisely. The build context is everything Docker sends to the daemon to build the image. If you don't ignore things like your entire .git history or your local node modules, or worse, .env files with secrets.
They all get bundled up and sent over, potentially ending up in your image layers, which means bigger images, slower builds, and huge security risks if secrets get in.
Nailed it. It saves build time, reduces image size, and crucially keeps sensitive stuff and development clutter out.
And the author sees this often.
Apparently so. He mentions running a Docker hosting company and seeing hundreds of Docker app every week, so he has a good perspective on common mistakes. It seems like a no-brainer, but clearly it's still missed.
Okay, good reminder. Always use .dockerignore. Next.
Bloated, single-stage Docker files.
The classic Docker file that does everything. Build, compile, test, and then just runs.
Yeah. The challenge from the article is, if your Dockerfile has all your build tools, compilers, and test dependencies in the final image, stop.
Why? What's the problem with that?
Well, two main things. Size and security. Your final production image doesn't need your compiler, your test runner, all your build time dev dependencies. That's just bloat, making the image huge.
And the security angle.
More software installed means a larger attack surface. If there's a vulnerability in your build tool chain, but it's sitting there in your production image, that's a risk you don't need to take.
So what's the solution?
Multi-stage builds. This is a really powerful Docker feature.
Explain how that works.
You basically define multiple from instructions in one Docker file. The first stage might be from node.20 as build. You copy your code in, run npm install, run npm run build, do whatever you need to create your production artifact.
Okay, so that's the build environment.
Right. Then you have a second stage, maybe from node.20 slim, a much smaller base image. And in this stage, you only copy the built artifacts from the first stage using copy-y from build.
Ah, I see. So you copy just the compiled code, like the dist folder, from the build stage into the clean slim stage.
Exactly. So the final image only contains the minimal runtime environment and your compiled application. No build tools, no dev dependencies, much smaller, much more secure.
That sounds like a huge improvement. Can we see a quick example?
Sure, it might look roughly like this.
Yeah.
Docker.
20 as build, workdir app, workdir app, copy package.json, run npm install, copy l, run npm run build, 20 slim, workdir app, hashtag copy only the build output from the build stage, copy y from build appdist.json, hashtag maybe copy node modules if needed, or run npm install production. Copy back from build.package.json. Run npm install production. Ignore scripts, prefer offline. cmd node, distindex.js.
Nice. You clearly separate build from runtime. Okay, last old habit.
Manual builds without leveraging the cache.
You mean just typing Docker build every single time and waiting?
Pretty much, yeah. Especially without taking advantage of modern build features. The key here is build kit.
Build kit, that's the newer build engine in Docker, right?
Exactly. You enable it often by setting the environment variable Docker build kit 1. It's much smarter about caching.
How so?
Well, basic Docker caching is layer-based. If a line in your Docker file changes, that layer and all subsequent layers are rebuilt. BuildKit is more intelligent, but the real power comes when you use cache mounts, especially for package managers.
Cache mounts, like mount type cache.
Yep. You can tell Docker, for instance, to mount a cache directory specifically for npm or pip or apt. So when you run npm install, it uses that persistent cache. The next time you build, even if other things changed, pulling dependencies is way faster because the cache is preserved independently of the image layers.
So it's not just faster, it's smarter caching.
Yeah.
Less redundant work.
Exactly. The article says it's not just faster, but smarter. It dramatically speeds up builds, especially in CI/CD or even local dev.
Okay, so we've covered the don'ts. Let's flick it. What should modern Docker usage look like in 2025?
Right. So imagine putting some of these pieces together in, say, a docker-compose file.
No version .field at the top.
Definitely not. You'd have your services defined. And for each service, you'd ideally have a health check block configured.
And you'd build the image using a multi-stage Docker file.
Yep, and specify the non-root user. You could even specify the user directly in the compose file sometimes, like user 1000.1000 using the UID-GID to ensure consistency.
Okay, so that covers the setup. But the article also talks about the development workflow, right? Dev containers, watch mode, and you. That sounds interesting.
Yeah, this is where it gets really cool for the day-to-day developer experience, or DX.
So how does it work?
A key piece is Docker Compose Watch. Have you used that?
I've heard of it, but haven't really dug in. What does it do?
It basically watches your source code files, and when you save a change, it can automatically rebuild the image and restart the service for you.
Ah, like live reload, but for the whole container build.
Sort of, yeah. You configure it in your compose file under a develop.section section usually. You tell it which paths to watch and what action to take, like rebuild.
Okay, I can see how that would speed things up.
Massively.
Yeah.
Combine that with using bind mounts.
Where you map a local directory directly into the container.
Right. So for some changes, maybe you don't even need a full rebuild. If your application supports hot reloading, like many Node.js frameworks do, a bind mount means the code inside the container changes instantly when you save locally. The running process might pick it up without even restarting.
So you get that near instant feedback loop even though you're running inside Docker?
Exactly.
Yeah.
And you're still using dockerignore to keep the build context clean and build kit caching with cache mounts to make any necessary rebuilds super fast.
What does that watch config look like? Is it complex?
Surprisingly simple, usually. Under your service, you might add YAML wash.path.src, or wherever your source code is, action.sync, hashtag or rebuild, depending on your needs, target.appsrc.path.package.action.action.rebuild, hashtag rebuild if dependencies change.
And people are finding this useful.
Oh, yeah. The article mentions comments from users who are like, wow, Docker Compose Watch exists. I need to try this. It really addresses that pain point of slow iteration cycles in Docker dev.
Okay, that makes sense. So it seems like a lot of the pushback against Docker, the criticisms you hear, maybe they're based on these older ways of using it.
That's precisely the argument Schultz makes.
Yeah.
He tackles two main groups. First, the Docker isn't good for production crowd.
Right. What's his response to them?
Pretty blunt again. It's not Docker's fault. It's yours.
Huh. Okay. Why yours?
Because, he argues, people run into problems because they didn't set things up right. They didn't add health checks, so Docker couldn't restart a failing service automatically.
Okay.
They didn't use multi-stage builds, so they ended up with these massive 2 GB junk images that were slow and insecure.
Right, the bloat problem.
And they ran everything as root, making them scared of potential security issues in their own setup. His point is, Docker can be solid for production, but you have to treat it like a production system and use the proper features.
Makes sense. Don't blame the hammer if you hit your thumb because you weren't holding it right.
Exactly. Then there's the second group. The Docker is bad for local dev crowd.
What's the take on them? Slow builds, painful debugging.
Again, the response is also wrong. You're probably using it wrong.
And the solution is the stuff we just talked about.
Yep. Docker Compose, watch for that live reload feel. Build kit cache mounts to make builds lightning fast. Bind volumes plus application hot reloading for instant code updates. He says you can get a really smooth, native-like DX.
DX being developer experience.
Right. And he throws down a bit of a gauntlet. If you're waiting 2 minutes for each build or watching logs from Docker logs -f, it's a skill issue, not a Docker issue.
Strong words, but it sounds like the tools are there if you learn to use them.
They are. And he points to comments from users, like someone named Oscar, who confirms they use Compose smoothly in both dev and production, kind of backing up that it's entirely possible.
Okay, so wrapping this up, what's the main takeaway here? The TLDR, if you will.
The core message, really, is that Docker has grown up. It's not just a developer toy anymore. It's a serious, battle-tested tool for the entire life cycle, dev and production. But you got to stop using it like it's still 2015.
Yeah.
You need to adopt the modern practices.
So quick recap of those actionable steps.
Okay, let's list them out. 1, ditch the version.field in compose files.
Got it.
2, add health checks, always.
Crucial.
3, use build kit and learn how to use cache mounts effectively.
Faster, smarter builds.
4, use multi-stage builds to keep final images lean and secure.
No more bloat.
5, run your containers as non-root users.
Security first.
And 6, for the love of whales, add a .dockerignore file.
Don't forget the whales. Okay. And the final sentiment.
Stop blaming the tool. Look at how you're using it first.
That's a solid summary. It really makes you think, doesn't it? Like, reflecting on this. What stands out to you, the listener? How has Docker changed for you? Or maybe which of these older habits did you suddenly realize you might still be doing?
And to leave you with a final thought, building on something from the source. There was a comment mentioned something like, one of the main ways to stay in the market is to maintain the legacy.
Interesting point.
Right. But the author's whole article pushes back against that, challenging these outdated beliefs about what Docker can or can't do. It makes me wonder, Beyond Docker, where else in our work, or maybe even in our learning, are we just maintaining the legacy?
Holding on to old ways just because.
Yeah, holding back because we're stuck on outdated beliefs about what's possible or efficient. When should we be challenging those assumptions more?
That's a really great question to ponder. Food for thought.
Definitely.
Well, thank you for joining us on this deep dive into the evolving world of Docker. Keep exploring, keep questioning, and maybe ditch a few of those 2015 habits